Today, we'll be demoing a project titled BLE Tagging and Localization. First of all, let me tell you what drove us to take up this project. We all know that finding misplaced object may require us to recollect the last time we had that object or do a physical search, which may prove to be tedious. Well, this problem we are trying to address in this project by connecting the objects to the internet, making them searchable, and leveraging the fact that smartphones are in every hand and internet is there everywhere. This is achievable by attaching tags to your objects and connecting them to your mobile devices through an application. But then what kind of tags? We have options like BLE, Wi-Fi, Zigbee tags. But the major concern to keep in mind while making a choice is power and connectivity. And BLE stands out amongst the others that I named in this respect. We can put to use the BLE module available on smartphones and other gadgets which form the part of our daily life. Well, this approach takes search to an all-new level by making it simple, efficient, and crowdsourced, wherein a larger community of users take part in searching for a misplaced object. Architecturally, there are three components in this project. The first one is a BLE node, which acts as a server, and then you have your mobile device, which will be running an application and which will serve as a client. And then we have a cloud, which is used as a central storage database. The nodes in our project are EcoBTs, which we use to tag objects. EcoBT was developed by our professor Pai Chow. It is a miniature versatile mode platform which is based on Bluetooth Low Energy technology. And then we have the application that is running on Android devices. These applications are developed to use BLE and GPS abilities of the device to scan and locate BLE tags attached to objects. Users can add their tags in the application, which connects to the tags and monitors them. The app also provides a feature to scan added tags and intuitively provides the distance of the tag from the device. As you can see here, I have the tag very close to the application, and it's showing that the tag is pretty close with a signal strength that is pretty high. Now, as I move the tag away from the device, the signal strength drops. This actually indicates the approximate distance of the tag from the device. And some of the other features that we provide in the application are you can view your tag on maps and also report a tag lost to initiate a collaborative search. The app also operates in the search mode, wherein it searches for lost tags in the background without you or without your intervention and reports the location of lost tags to the cloud. Well, here the cloud is nothing but a central storage where we actually save all the nodes information and user information. So we basically use two tables. First one to list out all the nodes that have been registered, and the second one to actually track the lost node information. And cloud also runs a set of services which actually enable us to retrieve data from the database and also to enable us to send notifications to the other applications whenever a user actually reports a tag lost or whenever a tag is found. Now, let us see a live demo of our project. Let's assume that I've tagged my car keys with a BLE tag and I've added the tag to my application. So once I add a tag through an application, so it gets recorded in the central database, which is there on the cloud. And as you can see in the video, so the table actually records important information about the tag, like the ID, the MAC address, the name, and the registered user who actually added the tag. Now, if I have to scan my car keys locally, so all that I have to do is go into my application and hit the start scan button. And as you can see, the car keys start showing up, and it also shows the distance at which it is. Now, let us consider the case wherein the tag is not in the vicinity of my device. Maybe I left it back somewhere, or I have misplaced it. So in this case, a local search is not possible because the tag and the device are no more connected. So to just demonstrate this, let me just turn off the Bluetooth settings of my device. So in this case, my tag is not connected to my device anymore. So the application is so coded that whenever the application feels that it's losing the connection with the tag, it takes a stamp of the location and stores it locally for the user to retrieve this location at a later stage. So if I have to know the last known location of my tag, so I just hit on this button and I can view the last known location on the maps, as you can see in the video. So this just gives me my tag's last known location. Now if I am not able to find the tag in that location, so it means that I've lost it. So in this case, I can report the tag as lost, report tag lost. So a lost report will be filed. Now let's just bring in another phone or another user, and as you can see here, he has got a notification saying that someone's lost a device, please help them find it. So as soon as the user clicks on this notification, he actually does a collaborative search, and his device, if it is in the range of the node, as it is in this case, captures the location and uploads it to the cloud, as you can see in the video. As you can see, this is the last table where the tag has been added when it was reported, and the latitude and the longitude of the tag have been updated after it is found. And what the cloud code does is, it sends out a notification to the reported user saying that your object was found. So once the owner clicks on that notification, it opens up a dialog saying that your tag was located, and the owner will be able to view the location on Google Maps, as you can see in this case. Thereby, with the help of collaborative search, with the help of other people, other registered users, a person who's lost his tag was able to find his tag, and thus the search was complete. Some of the enhancements to the project are implementing power saving modes to increase lifespan of the tags, include profile to read the accelerometer values to improve search accuracy and reliability, and likewise other profiles which facilitate search. Implement logic to push notifications only to clients in a pertinent region to avoid broadcasting to all registered users. And one more important thing would be to expand the idea to installing base stations at prime locations to reduce dependency on the crowd. Finally, conclusion of this project is that it describes how efficiently and effectively we can locate lost objects, leveraging the power of efficient technologies like Bluetooth Low Energy, Android applications running on smartphones, GPS, and the cloud. One of the most compelling features of this project is the ability to locate the lost object utilizing the community. Though it relies on the benevolence of the people involved in the community, but from an optimistic point of view, it is beneficial to everybody. Thank you.